Okay, ji, Assalamu alaikum. Let's start our discussion for today. So this is basically 16th and the last week of this semester, right? So we have 2 hours today, 1 hour tomorrow. So we'll try wrap up our contents within these 3 hours, right? And then tomorrow maybe or today, if we get some time, we'll surely discuss your final exam as well, right? I'll also seek your feedback and based on that we'll be designing the final exam, so don't worry about it. There will be a detailed discussion on final exam as well, right? But first we need to complete the contents, right? So other than these 3 hours, if you still face some problem, right, individually or as a group, you are welcome to let me know and we can hold an online session to discuss your queries, right? But that we'll be doing after Wednesday. Means first we complete all our contact hours, and then if you need some additional guidance, I'll be available. um, if it's a group combined problem, we can have a joint session. If it's individual problem, I'll be available for a one-to-one session as well, right? Okay, so with that, let's start our technical discussion, right? So just to give you an idea what we were looking at, we were looking at how you can write data to file, store your data on the disk, so that when your program terminates, your data is not lost, right? So you can maybe come back after 1 week and retrieve the data that you saved on the disk, because whatever you save on the disk is permanent, but the variables are in the memory, and they are gone as soon as your program terminates, right? So we'll be continuing our discussion. Okay, so let me just go to the board and quickly recall you that what we have been doing. So we have been making objects of these classes of stream, which is short for output file stream, and if stream, which is short for input file stream. So off stream is for writing data, right? Because you are outputting something from your program. If stream is for reading data, means you are reading from a file from the disk into your program, right? And but what we have done so far, we have used stream insertion and stream extraction operators to read and write data, right? Just like you use with cin and cout. So that's okay, that's fine. But last time, towards the end of the session, we discussed that when you are using these operators, everything is written in the file in the form of character, as a sequence of character, right? So if I'm writing a text, it's okay. But if I'm writing an integer using these operators, right? So the problem is that when I'm writing an integer with 2 digits, these are two characters. So it means they will take 16 bytes in the, sorry, 16 bits or 2 bytes on the file. Similarly, if the integer has 3 digits, it will take 3 bytes. If it has a 4, it will take 4 bytes, and so on. So there are many problems with this, because you see, if you are using these operators and I am writing multiple integers, so I will need to put a space or a new line character between them, so that I know where one integer is ending and the other is starting. Another problem is that if I ask you, okay, I don't need all the data, just read integer number 3, this one. So you don't know where it is located in the file, right? Because every integer is taking different number of bytes. So what we want is what we were discussing last time, that ideally when we store something on the disk, it should have the same size as it has in the memory. Okay, so for example, if integer is 4 bytes, then in the disk, sorry, in the file as well, it should have 4 bytes. And the advantage would be that if every integer is 4 bytes, so if I ask you read integer number 100, so you simply need to multiply, and you can compute what byte number it is present at. And then you also have the seek functions. You can directly jump at that location in the file and read the desired data, right? So this we'll be discussing today. Okay, so let me do a concrete example. And what we said last time, that instead of using these operators, now we'll be replacing these operators by two member functions. So instead of this, we have a function in offstream class which is called write function. Okay, so you will not be using this operator now, you'll be using write function. Similarly, for this, we'll be using the read function. Okay, so uh, from now onwards, when you are writing data to file, I would recommend, if it's a string, it's okay, you can directly use the same operator. But if you are writing integers or anything else, or maybe objects of a class, then for writing, we'll be using the write function, and for reading, we'll be using the read function, right? So we'll do an example in which I'll be writing two integers to the file, And then I'll also be showing you file pointer location, that how file pointer is moving, so that you are convinced that once we write one integer, file pointer is at byte 4. When I write second integer, file pointer is byte 8, and so on. Okay, so let me do that example, and then we can discuss it further. Okay, so I'll since I have to write data, so I will make an object of class of string. Let's call it f, and we need to give a name of a file, right? So when you are writing using write function, the first thing is that you open the file in binary mode. Okay, I told you about this mode, but we did not discuss it, so today is the time that we discuss that. When you open the file in binary mode, the advantage is that if integer is say 4 bytes in the memory, in the file as well it will take 4 bytes, right? And similarly, when you have to name the file, you can give any name, right? But by convention, normally once you are storing data, so it's by convention you can give it the extension .dat, right? Dat is short for data. Although you can give any extension like xyz abc, they are all fine, right? But if you're following the convention which most of the people normally do, so I would recommend you that once you are storing some data, give it extension .dat, right? So that anyone who actually sees this file, they would know that some data is being stored here, right? Otherwise it won't make any difference even if you are using anything else. So let me call it say records dot dat. Okay, so this is the name of the file in which I want to write, and this time we are opening it in binary mode. So when I open it in binary mode, so the advantage would be that when I'll be writing things, they will be taking the same size as they take in the memory. Okay, so now what we'll do, we'll take an integer in our program and we'll try save it in a disk, and then we'll try read it. Okay, so this is the whole sequence that will be following. Okay, so let me take an integer, say x, which is 5. Now you want to write this x in the file. Okay, so previously we have been doing this. Okay, but now we'll not do this because we have already discussed what are the disadvantages of this. So now what you will do, you will use member function, which is write. Since write function is a member of this class, so you use f, which is the object dot write. So you see this syntax is exactly the same that you have been doing with your own classes. The only difference is that now f is an object of a class which you have not created, it is already there, right? So it is exactly the same syntax. If it's a class student, you write student s dot display. Now you're writing f, which is a object of a class which already exists, and you write f dot write. Okay, now this write function is slightly tricky, so I'll discuss it. I'll spend some time on it. Let me first tell you what are the arguments of this write function. There are two arguments of this function. Okay, and what are those arguments? Okay, let me just change the color. The first argument is address of the variable which you want to write. Okay, let me write which you want to write. So the first argument is the address of variable which you want to write, and the second argument is the number of bytes that you want to write. Okay, now you see, first let me write something very trivial, but that would not be correct, but we'll improve it with discussion. So we are trying to write an integer. Integer is in variable x. So what is the address of x? Address of x is ampersand x, as you already know. Okay, this is the address of x. So maybe this is what I should write in the first argument. And how many bytes an integer takes? An integer takes 4 bytes. So maybe I can write 4 here. Okay. Um, to some extent, it looks correct, right? But we need to improve it. So you see, as I keep telling you, it's not a good idea that I just hard code some fixed numbers in my program. So, and it is also possible that if you are changing the compiler, maybe on some machines, integer is taking 2 bytes, right? Not necessarily on every compiler and every machine integer will take 4 bytes. So rather than fixing it, what we can do is we have an something available in C++ which is called size of. Okay, so if you give size of, if you write size of int, and you just display it, it will print 4 on the screen, right? Similarly, if you write size of table, which is 8 byte, it will print 8 on the screen. This size of can take data type as well as variable. So you can write size of int, but you can also write size of x. And since x is an integer, so this will also return you 4, right? So the conclusion of this discussion is, instead of fixing how many bytes we want to write, we can use size of, which can compute the size of a data type. So you can write size of integer here, means you can directly give int here, or you can also write x here, which will actually give you 4. Okay, so you can directly write 4 here, but that is not a good idea. That's why what I'll do, I'll replace it with this size of. Okay, so let me just gain some space and then I write it. Okay, so instead of this, we replace it with size of. So here I'm writing size of x. Okay, and as I told you, you can also write size of integer. Okay, so the second argument is done. It is final. Now we come back to the first argument, which we need to discuss something more about it. Okay, so let me just gain some space on the board and then I write. Okay, so as I told you, the first argument is address of variable which you want to write. We want to write x, address is address of x. It logically it seems correct. Okay, it is actually correct, but it is incomplete. Why it is incomplete? If you see the function declaration of f dot write, okay, so the first argument there is written like this, character pointer. It means it needs address of a character as an input of a byte. Okay, but you see, we are not storing a character, we are storing an integer, and later on we will be storing objects of classes, right? So when you write this function, there is a mismatch that the function requires a character pointer as input and you are giving it a integer pointer. Okay, and maybe when you have a class point, you will giving it address of a point. And you see, you can create any class, point, student, employee. So it is not possible that this function is handling every type of pointer, because you can create whatever class you want. So the guys who have written the compiler, they can't know in advance that what classes the developers will create, right? So they have to keep things generic. So in order to keep things generic, you see, we have this function requires a character pointer, but I might be passing address of integer, address of point, address of float, or anything to this first argument. So in order to do that, we have something which I think you have not seen previously, that we need to do a typecasting, right? That we need to convert from one type to another type. And this you will be doing every time you are using this write function. Okay, so instead of this, uh, let me just write it. It might appear a bit scary to you when you look at it for the first time. So you will write reinterpret. This is a keyword, okay? Cast, okay? This is a keyword in C++, and here you write character pointer. So now what is it saying? It is saying that this is an integer pointer. This is address of an integer, but convert it into a character pointer. Treat it as a character pointer. Why we are writing this part, which is a part of this function, you will always have to write it. And the reason is that the write function needs a character pointer as an input, but we are passing it address of an integer. It is not a address of a character. Similarly, later on you will be passing it something else. So every time you use the write function and you are not writing a character, then this is the part that you always need to write. Reinterpret cast character pointer, which is telling your program that treat it as a character pointer, so that it does not give you a syntax error, right? Because otherwise it will not compile, because what you are passing will not match with what the function is expecting. Now let me write this program, show you the output, and then maybe we can discuss it. Okay, so let me go to the compiler. Okay. Okay, you can ignore the point class that we'll be using in the next example. Presently, I'm just writing, you can say integer. Okay, so I already have this file. Let me just get rid of it. So we say off string f, name of the file, record dot data, and we want to open it in binary mode, right? So this is what we already know. Then I take int x is 10, okay, and I want to write this x in the file, okay. So what I do, f dot write, okay. um, First argument is address of x, and the second argument is the number of bytes that you want to write, okay. But as I told you, this function needs a character pointer, okay. So you have to write it stepwise, right? First write this and then convert this pointer into character pointer, if that will be easier for you to understand and write, at least in the beginning, right? So you see, f dot write needs two inputs: address of what I want to write, I have written address of x, how many bytes I want to write, size of x, which will give me 4. Now just to convert this into character pointer, you can simply use this reinterpret cast character pointer, that's it. Okay, so now we expect that this statement will write 10 to the file. Okay, and if you want to convince yourself, let's say we also print the value of the file pointer. Okay, I told you there's a file pointer which you are not managing, but it is moving as you are writing data to the file, and the tell function can be used to see the location of the file pointer. Okay, so I'll just write this and okay, now let's write one more integer to the file. Okay, so I take another integer y and I take it to be 1000. Okay, now I'll again do exactly the same thing. I'll just copy these two lines, paste them here, but this time I'm not writing x, I'm writing y. So this is y. Okay, so we are writing two integers to the file, and it's always a good idea that once you are done, you close the file. So I write f dot close. Okay, now let me just run this program. So a file will be created, but you see this time the file will not be readable because you are creating it in the binary mode. Okay, so you see this is a file which is created, but you don't see 100 or 1000 here, okay, because we are writing in the binary mode. But what is important is the output. Just look at the output. When I write one integer, the first integer, which is x, it is taking bytes 0, 1, 2, and 3. It is taking 4 bytes. So now the file pointer is at 4. Okay, and when I write the second integer, which has say 4 digits, it is also taking 4 bytes, and now the file pointer is at 8. So now you see the output, file pointer is at 4 and 8. It means irrespective of the number of digits in the integer, both are taking 4 bytes, which is the same as size in the memory. But this was not the case when we were using stream insertion and extraction operators, because there everything was written in the form of characters, right? So this is the advantage. The only slightly you can say challenging part could be this reinterpret cast, right? But since you will be doing it almost every time, so with some examples you will get used to it. All you need to know is keep in mind what is the input, address of variable which you want to write, and how many bytes you want to write, and just convert that address into a character pointer, right? So if you keep in mind this sequence, then it will not appear as scary to you as it might be in the first look. Okay, so maybe we can have some discussion on this example before I read this these two integers. Okay, now we have written these two integers. In the next example, I will try to read these integers and print them on the screen. Okay, but before that, let's have some queries. Okay, now we have data which is written to a file. Okay, now I will change this program. Okay, and we will try to read the data from the file. Whatever data we have written, will maybe you stored it in on the disk, and later on you can pass this file to someone else. And now we need to write a program which can read this data. Okay, so let's change this program. So for reading we use if stream, so I will change the name of the class. Okay, let's keep the same object f, and name of the file is the same, and we want to read in binary mode. Okay, now let me just change few things. Yeah. So off stream has a function write, because it has to write data, and you can guess if stream has to read data, so it will have a function read, it will not have a function write. So I change this function from write to read. Okay, now when you read data, you see the syntax of this read function is exactly the same as write function. There is no difference at all. You see, I just changed um, write to read, and rest everything is exactly the same. I'm intentionally changing the name of the variable because if when you were writing the variable was x, you can read it in a. It has to be an integer, right? So I have intentionally changed it to a so that you don't think that if variable x was written, I need x to store it. You just need 4 bytes to store that integer. So just to make it clear, I have changed variable from x to a. Now, how will this read function work? Read function has exactly the same arguments as write function. The first argument is address of variable in which you want to read. We want to read in a, so I have given address of a. And as we always do, we have converted it into a character point. How many bytes you want to read? An integer is a 4 byte. I want to read 4 bytes, so I write size of a. You can also write 4 here. You can also write size of int. Okay. And if we want to check whatever we have read is correct or not, we can print that data read from file was this, which is in a. Okay, so now we have read the first integer. Since there are two integers, we know, so let's read the second integer as well in the same variable a, and let's display it. Okay, so now what we expect, I don't remember, I think we had written 10 and 1000, something like that. So when we read data, we expect the same data to be read which was written. Now I have executed this program, and at the bottom of the screen you can see the output. Now you see the first variable we read is 10, which is displayed on the screen. The second variable we read is 1000. Okay, so whatever we had read, we had written, we are able to read it, we are able to display it, and we are convinced that what data we saved on the disk is correctly retrieved when we try to read it, right? So now we have seen how you can write data using the same number of bytes as in memory, and how you can read data back. Okay, of course it's a very basic program because we are not searching for something, or we are not jumping at some point in the file, right? But that we'll see in the coming example, right? So let me know if you have any queries from this particular example. Okay, now we will not be looking at any new concept. These existing concepts will be explained through multiple examples, right? The only new concept was read and write, which we have seen through one basic example. But in rest of the examples, we'll be using these two functions as well as some of our previous knowledge to write very useful programs, right? Okay, so you see, writing, as I told you, writing integers to a file is not very useful. Means if I have a list of integer, what possibly I can do with that? So actually, it makes more sense if you are writing complete objects to the disk, right? So you can actually make a very useful program simply using C++ that can maybe a management system for a chemist or for a small organization or for a grocery store, something like that. Okay, so to save time, I already created this class point, right? Because every time we see something new, we take this point class example as we have been doing throughout the semester, okay? So first I'll be writing this, and then maybe we'll do an example from the real world where we have a student or an employee class, and we'll be saving it to a file, and we'll be searching for some data, okay? So let me just get rid of all this. Now what we want. Now we have a class point which has two data members, as you already know, a constructor, a display function, and a set function, nothing much, okay? Now we want to store objects of this class on the disk. Means I will create a point and I want that point to be stored. Now one important thing that you should know is that when you store object of a class on the disk, only the data of that object is stored, functions are not stored, right? Because you see, it is data that we care about. We don't need to store the functions, because when we will read data, we can use those functions to display something or do whatever we want. Okay, so this is important, that when you will write when you will try to save an object of class point. So let me make point p1. P1 is say 2 3. Okay, p1 has two integers. Integer is 4 bytes. So when you write size of p1, right, say size of p1, it will give you 8. Why 8? 4 bytes for one integer x, 4 bytes for y. 4 plus 4 is 8. So it means every point object will take 8 bytes on the file, which makes sense, right? If you have 3 integers, it will take 12 bytes and so on. You can simply count the size of every data member, you can add them, and that will be the total size of that object. Okay, now let's just write this object to the file. Okay, so as we already know, we created a point. Now we'll write f dot write address of p1 and size of p1. You can write size of p1, you can also write size of point, both are same thing. Okay, and as I told you, you need to convert it to character pointers. So there you go. Okay, so now it has been converted to a character pointer. Okay, and then maybe let's write one more point. So you can simply write point p2, which is say 4 5. Okay, and you can use exactly the same statement to write this p2 in the file as well. Okay, but before that, I also need to open a file. So off stream f, let's call it points.dat, and let's open it in binary mode. Okay, so once we are done, we can close this file. And you see here I am giving fixed values. You can easily have ask the user to enter the x coordinate, enter the y coordinate, and then you can create objects of point class, and then you can save them to the file. Okay, so now you can run this program, and both of these points will be stored on the disk, right? So since we did not display anything, you don't see anything in the output, but this file points.dat is created, and these 2 points are stored there, right? And you can go and read, just change, just like we did previously. You can change off stream to if stream. You can change write to read, and you can display these points. Okay, rather let me do that so that you are convinced. So I am changing this. I take a point p1. Okay, I will read data in this p, and I will display it. Okay, so instead of write, you simply write read here. So whatever you have read, if you want to display it, you can write p1 dot, we have a display function, so that we know what we have read from the file. Okay, so rest everything stays the same. So you can actually, the first object we had written was 2 3. Now you see point is 2 3. This is displayed on the screen. If you want to read the second point, you simply repeat. I copy these statements, I paste them again. So now they will read the second point as well. And the second point was, I think, 4 5. So now we should have 2 3 as the first object which is read, and 4 5 as the second object that we read from the disk. So now you can see the output. Point is 2 3. This is the first object that we had written. Point is 4 5. This is the second object that we had written, right? So this was an example similar to what you had seen in the previous example, but now rather than writing an integer to a file, we are writing a complete object to the file. Okay, so this is what is different. And when you write an object, it is important that you must remember only data of that object is written. Functions are not stored. Okay, and how do you count the size? This class has 2 integers. You simply add 4 bytes for x, 4 bytes for y. So one object of point class is taking 8 bytes. 4 plus 4 is 8 bytes, right? So this is one example. Now if you have any queries related to this, we can discuss those. Okay, now with all that discussion, now we are in a position to write some very useful programs in which we can actually directly fetch a record, right, rather than reading everything. Okay, so this this type of file that we'll be making is called a random access file. We have already seen it, but I did not introduce this terminology earlier. You see, when you are using these operators, if there is something here at the end of the file, you cannot directly jump here. Okay, you have to read all this data, and then you know, because you don't know where it is located. Okay, if I ask you that read the last integer in this file, so if you are using these operators, you will not be able to do that. You will have to sequentially read all data, and then you will find it. So that's why they were called sequential access files, what we were doing previously. But now when we are using read and write functions, these are called random access file. And why they are called so? Because now we can directly jump to any record in the file. In order to explain this, let's take the example of point class, and let's suppose you have written 5 objects of this class in a file. Okay, so this is file. I have record number 1, which is say p1, which is 1 1. Then I have p2, which is 2 2. Okay, then we have p3, the third point, which is 3 3. Then I write p4, which is like 4 4. And then I write p5, which is 5 5. And maybe p6, which is 6 6. Okay, so this is just for discussion purposes that I have drawn like this. So this is some data which is written to a file. So we have 6 objects of point class which we have written to this file point dot data. Okay, this is the name of the file in which we are storing this. Okay, so now you see what point has int x and int y. 4 bytes, 4 bytes. 4 plus 4 is 8. So it means this one point is taking 8 bytes. This is also taking 8. Okay, this is an important discussion, so please I would request your attention. um, every object is taking 8 bytes, total 6 point, it means 48 bytes. Now if we say okay, this is point 1, which 8 bytes it is taking? 0. Okay, this is 0 1 2 3 4 5 6 7, means the first p1 is taking these 8 bytes. So it means if it is at 0, then where is p2? P2 is at 8. Okay, p3 is at 16. You simply keep on adding 8. This one is at 24, this is at 32, and this is at 40. So now you see, since we know that every object is taking 8 bytes because we are writing objects of one class for the time being, so now we know where a particular point object is. Okay, and how do we know that? Just to explain it further, let's say I ask you, okay, where is p4? Okay, where is p4? So you say okay, p4 is 24, you can see from here, but if you have to calculate it, then how will you do that? Okay, so you see 4, because we are looking for the 4 objects. I subtract 1. Why I'm subtracting 1? Because we are starting at 0. Okay, and how do you get 24? What should I put here? I should put 8 here. So you see 3 into 8 is 24, and it is actually at 24. Similarly, if I ask you where is the 6th object, tell me the address of 6th object. So what you do? 6 minus 1 into 8, which is 40. This is 40, this is 40. Okay, and it also works for first object. You see, if I ask you what is the address of first object, you will say 1 minus 1 into 8, which is 0, and this is 0. So now you see you have a very good way of finding. If I say tell me address of object number 5, you will say 5 minus 1 into 8. Why 8? Because 8 is the size of one object. Okay, as I explained you through this example. So in other words, we can generalize it. Okay, and if I generalize it, I ask you where is object number k? Okay, because we have to in programming we have to generalize things. So you will say k minus 1 into 8, right? If I ask you where is the third object, k is 3. 3 minus 1 is 2. 2 into 8 is 16. Third object is at 16. Now you see this 8 also does not look nice. So you, if you are smart, you should already be saying that why not, what is this 8? 8 is size of one object. And how do you find size? You can write size of point. which is actually 8, but it's much better if we write it like this so that it automatically calculates it. So now you see this is our golden expression, which is giving us a number. Okay, and this will work for every class. Okay, for example, instead of point, if I write student, so whatever is the size of the student, if I ask you where is object number 4, you will say 4 minus 1 into whatever is the size, and you will say it is at 24, so it is at 24. And once you know this byte number, okay, you see, simply knowing that it is at 24 is not very useful. I actually want to read this. So now once you have this number, let's call it say location. Now is the time that you can pass this location to seek function. And what will happen when you open the file, your file pointer was here. You can now directly jump to 24, and your file pointer will skip all of these. It will come to 24, and then you can use the read function and you can directly read record number 4. Now you see the advantage that when we have every record of fixed size, which is 8 in this example, I exactly know where a particular record is. Okay, record number 1, 2, 3, 4, I can find their byte number. And once I have the byte number, I also have a seek function which can take my file pointer to that location. So first I calculate the location, then I pass it to seek function, so I can directly read record number 4 or 5 without the need of reading the previous record. That is why we call it a random access file. Random access means you can go to any location in the file. And why we can go? Because we know the location, right? We have done something smart. We have ensured that every object is of same size, so that's why we can do it. Okay, so um, this is the general idea. I'll be writing a complete program of this, right? But if you have any problems understanding this idea, then we can discuss. And then I will write a complete program which is actually exploiting this idea. Okay, and now with all that information, we'll be writing a very useful program in which we'll be writing multiple objects of a class in a file. Okay, and then we'll ask the user, okay, which record number you want to read. Okay, and he will directly be able to read that object. Okay, so it would be a slightly lengthy program. So what I will do, I will write two separate programs so that we can discuss them separately. So we already have the point class. Okay, so this time we'll ask the user that how many records you want to write. Okay, so I'm making off stream say f point dot dat binary. Okay, and I take a variable count. Okay, and I will ask user how many records you want to enter. You can also use a do while loop. Okay, but to save time, I'm not using a do while loop, but of course you can use a do while loop. The program will be more flexible. Okay, so I will write how many records you want to write, and then I'll ask user count. Okay, now what we do, we take a for loop for integer I equals 0, I less than count. Okay, and I plus plus. So now what we'll do, will we have a for loop because user wants to write multiple records in a file. Okay, and every time we'll also take input from the user. Okay, so I take a point p, I take int a comma b. Okay, and I ask the user, okay, enter x coordinate, and I have seen. Then I say enter y coordinate, and I have seen b. Okay, and what I do now, I say p dot set a comma b. So what will happen, user will enter values in a and b. I call the set function of point class, which you can see on the top. Here is the set function. So whatever I pass, it will go to x and y, right? So the x and y coordinates of point class. Now we are not fixing the values. We are letting user, you can say, enter the values. Now p has values. P is something you want to save in the file. Okay, so you already know how to do that. F dot write address of P and size of P. Okay, and as we always do, convert this address into a character pointer as well. So reinterpret cast character pointer like this. Now what will happen? This loop will execute for the first time. You will enter some data. You set that data in x and y coordinates of p, and then you write that p to the file. Then this loop will execute again. Since p is free now, you can keep on taking data in p. Okay, you see, I'm not having multiple variable. I'm using just one variable because I get value in that variable. I write it to the file. Now that variable is free. Then you get the second input, you write it to the file. So you can keep on doing it as many times as you like. Okay, and once you are done, you can actually close this file. Okay, so let's see if it works fine or there's some error. Let me just compile it. Yeah, now you see it is saying how many records you want to write. So let's write 4 records. So I enter 4. Okay, so it means that the loop will execute 4 times. Okay, so it is asking me enter x coordinate. So 1, enter y coordinate 1. Okay, I have entered 1 1. They now the set function will be called. They will go to p, and then p will be saved in the file. Okay, so now it is asking me for the second point, enter x coordinate. So I'll enter 2 and 2 for the y coordinate, right? Similarly 3 and 3. Okay, and then 4 and 4. Okay, so I have entered 4 points. The program has terminated. All those points are now saved in the file which we are calling point.dat. Okay, now what we want to do, we will now try to read one of those points, and we'll ask the user that which point you want to read. Okay, now we'll not be reading all the points. I'll just be asking user which object you want to read, and then we'll be finding it byte number. We'll using the seek function, we'll be reading that point. Okay, so now let's do that. Okay, so for reading we make object of fstring. Okay, what was the name of the file? Point.dat, and I was binary. Okay, now you see, I will ask the user integer, say record number. So I will ask the user enter record number to read. Say in record number. Okay, so suppose user says 1 2 3 or 4, because we have 4 records or 4 objects in the file. Now you see, we need to compute the location. So if you remember the discussion that we did a little while back, if you know the record number, what do? You write record number -1, and what do? You multiply it with size of point. Okay, so this is exactly the same expression. Let me just recall you, which we were doing here. Okay, k -1 into size of point. Instead of k, the variable I have in my program is record number. Otherwise, it is the same expression that we used. Now we know the location. What we need to do, we need to go to that location in the file. Okay, so for that, you already know what do we have. We have f dot seek g. Okay, why g? Because with if stream you use g, with off stream you use p. Okay, so don't be confused with this g and p. So we take it to that location. Okay, now your file pointer is at the location from where you want to read. So you will take an object point p. Why I have taken an object? Because when you read data, you have to store it in some object. So I will store it in p, and then you write f dot read address of p and size of p, and then it's better to convert it into a character pointer. So I do this. Okay, now just to be sure that what we have read, we can also display it. Okay, so that we see on the screen what we have read. And once you are done, you can close this file. Okay, so let's run this program to see if it is correct or there are some errors. It seems to be correct. Okay, now you see it is asking me enter record number to read. I'll give it say 3. Okay, and you see point is 3 3. If you remember, in the first object I had written 1 1 2 2 3 3 4 4. Okay, so I say I want third object, and just so that I remember what was third object, it is 3 3. You can run this program again. Okay, and suppose I now say I want to read record number 4. Point is 4 4. Okay, but you have to be careful that you have to give it a legal value. Okay, if you are giving some illegal value to seek G, an exception will occur. For example, you cannot give it a negative value, or you should not give it a value which is beyond the file. Okay, because if you have 4 records in the file and you give it 1000, then that is an illegal value. So it is the responsibility of a programmer to make sure that you are giving a legal value to this variable. Otherwise it will cause problems. Okay, now before I show you some new example, I'll go back to slides and repeat all of these examples which we have done in this 1 hour. And once we are convinced, we have sort of a recap of all this, then we'll see some other example, right? But all the examples that now you will see, as I told you, no new concept will be introduced. The existing concepts will be used. Okay, but let's first have a recap of what we have seen so far. So I think this was the first example we had done today, where we were writing 2 integers to the file. Okay, so we have an integer x, integer a, but as I told you, instead of writing like this, which is not recommended because it will write everything as a sequence of character, you will use the function write. This function has 2 arguments. First argument is address of variable you want to write. I want to write x, and how many bytes you want to write. So it is an integer, so you could have written 4 here, but we say let the program automatically calculate this size, so we use size of. And we need to convert everything into character pointer, which is called casting, converting from one data type to another. That's why you have to write it every time, right? And it's better that you write this complete version. On some compilers, only if you write like this, that will also work, right? But I appreciate if you write this complete version. So now we have written 2 integers, and now when you are writing the integer, the first integer is taking 4 bytes, the second is taking 4 bytes. So initially your file pointer would be at 4, sorry, at 0. When you write one integer, it will be at 4. When you write another integer, it will be at 8. And you can actually call the tell function to actually see that file pointer is moving. And then this is the, you can say, program to read data from the same file. So instead of write, now you have read function. Previously we had write function. Syntax is exactly the same. You see, nothing is changed. If you use write here, it will write. If you use read here, it will read. But of course, a write function can be used with off stream. Read function can be used with if stream. Okay, if you try to do it otherwise, it will give you an error. It will not work. Okay, so now we read whatever we had written from the in the file in this variable data. And if you want to convince yourself, you can print, so that you know that it is printing what you had actually written to the file. Then we said, okay, writing integers to a file is not very useful. So let's write objects of a class. So we have a class point which has 2 integers. And when you write an object of point, only the data is written. Okay, these functions, they are not written in the disk, only data is written. And since there are 2 integers, so the total size would be 8 bytes. So every time you write point objects, 8 bytes are stored in the file. Okay, so here we are writing 2 objects, 1 2 and 3 4. You see exactly the same statement, nothing changing. The only thing I have changed variable name here. Okay, rest, once you understand this, you can write whatever you want. And then we said, okay, if we want to directly access a record, then now we have a mechanism to do that. So for example, I have 5 records in the file. Every record is taking 100 bytes in this example. So the first record is from 0 to 99. It means it is at starting at byte 0. Then the second is at 100, 200, 300, 400, and so on. So if I ask you, where is record number 4? So what you need to do, 4 minus 1 into 100. Why 100? Because 100 is the size of one block. And why minus 1? Because we start at 0. It is giving you 300, which is actually where this is starting. And if we want to generalize, we said, if you know the record number, which is n, you say n minus 1, and this is size of object, which in this example was 100. But if you use size of, it will automatically calculate it. So you will not have to add manually and then write it. Okay. And then I showed you this example with the point, that now you see we have 5 point objects. Every object is taking 8 bytes, so you can directly know the location of an object, and then you can use the seek function to move the file pointer there and read data from there. Okay, so this was the example that I just did at the end, that we asked the user how many records you want to enter. As I told you, you can also use a do while loop here so that you don't have to enter this, but it's your choice. Okay, so in the loop, we take an object, we ask user to enter x and y, then we set it to p, and then we write p in the file. So we keep on repeating this as long as the user wants, and when all data is written to the file, you close the file, and now you can ask the user which record number you want to read. So users can say, okay, I want record number, say 3. So this is the formula we have discussed, which will tell you where that record is lying in the file. So we get this location, we pass this location to the seek function, and then we read data from that location. So we just saw the output that it allows us to read data from the location that we want, right? So this was, you can say, a relatively more improved or enhanced example, which is more similar to real world. We'll further enhance it, but before that, if you have any queries, we can discuss those. Okay, now let's see one more example, but this time now I have changed the class. Okay, that instead of point, suppose we want to store data of students, right? And we are having enrollment number and a GPA of a student. You have a constructor in the class, you have a function to display the data members, do you have an input function, and then you have function get and set functions, right? Of course you can have other functions in the class as well. Okay, so this time the example I'll be showing you is exactly the same concept, nothing new, but what I will change that just for a change, I'll be making an object of f stream, right? Because f stream can read data as well as write data. Okay, so previously we have been making two separate programs, one for reading, one for writing. Now let's make one single program in which we are reading and writing. Okay, so this is the difference. And of course, just to tell you that you can also use fstream and you can also read and write in a single program, this is the only objective, right? Otherwise you don't need to have a single program for reading and writing. It is perfectly okay that one program is writing data, the other is reading. That is perfectly okay, right? But just to give you another flavor, I have included this example because it will also introduce you with some slightly you can say different options. Okay, now here we'll be asking the user that how many records we will not be asking the number, we'll just using a do while loop, that if the user wants to continue, they can do as long as they like. That's why I have this character choice. Okay, if it is yes, user will keep on entering data. This is the student object in which I'll be storing data, and you see now we are making an object of f stream. F stream can read and f stream can write, it can do both of the things. Okay, now when you call the constructor, okay, or you call the open function, both are the same thing. This is the name of the file. Okay, when we are making object of off stream can only write, so we don't need to tell the program that we want to write. If you do, that's okay, but even if you don't, it's okay. If stream can only read, so we don't need to tell that we want to read because it is understood that it cannot write. But when you are making an object of f stream, now it can do both the things, it can write as well as read. So you need to tell your program that you need to do both of these, and you can do one of these as well. So what is the way to tell? You see, this might be new for you. Previously we have only been writing ios binary. Okay, but now I need other flags as well. Okay, I need to write, I need to read. So out is for writing, in is for reading. Okay, so what we do, you use this logical or, and you can put whatever you want to do. So we have binary, we want to read in the same program, we want to write in the same program, and this is optional app. If you remember, in the previous week I told you, if you are opening a file in out, every time you run the program a new file is created, the previous contents are gone. If you want that, okay, the file already has some data here, when I run this program again, the new data should not override the previous data, it should be appended at the end of the file. Then you close the program, you come back after 1 week. So whatever data you are entering, it will keep on adding at the end of the file. So previous data is not lost. So it depends on your choice what you want to do. If you want to keep the previous data, you can use the append mode. If you don't, you can ignore it. So every time you run the program, a new file will be created. Okay, it's your choice. But the important thing is that this might be new for you, that since we are using fstream, so we need to tell the program that we are reading as well as writing. And once you have more than one flag, you put this or, which is single bar between these different ones. Okay. Now we have a do while loop. Okay. And we'll continue the loop as long as the user wants. And what is happening in do while loop? Nothing much. We say enter student data. Okay. And we have a function input s dot input. So where user will enter all the data like GPA and ID or anything else. Once we have all the data in this S, we simply say f dot write, write this f in the file, and how many bytes? These many bytes. So you see, it's a very small piece of code, but it will keep on writing data as long as you want. Now all the data is written to the file. Now we'll be reading within the same program. Okay, we are not making a separate program. So since once you were writing data, what was happening? Your file pointer was going down, 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 and maybe your file pointer is here. Now, if you want to read data, right, since you are using the same object, okay, we are not creating a new object. When you create a new object, file pointer is automatically at byte 0. But if you are using the same object f, now the file pointer is here. So you see, this is an important line, f dot seek g0, because if my file pointer was here, I need to bring it back to the beginning of the file. And then I read the first record. Okay. And since we don't know how many records are there, so I told you you can use this function while not end of file, means as long as there is some data in the file, you read the first record, you call it, you print it, then you try to read the next record. It will read the next record, it will print it. So it will keep on going, and when there is no more data in the file, this end of file will actually tell you that the file has terminated and you will come out of this loop. Okay, so now I'll go back to the previous slide. You see, here we are writing data and here we are reading data, and we have made an object of fstream. And using fstream, it allows us to read and write using the same object. Although I personally don't recommend it, but just in case, since it is allowed, so I have included an example of this as well. Okay. And then when you don't know how many records are there, you can use this end of file function in a while loop. So as long as there is data in the file, you can keep, it will keep on executing the loop. And when there is no data in the file, you will come out of this loop and the program will terminate, right? So again, you see, this you can do, but there's also a way in which you can count how many records are in a file. Okay, so let me explain that, and maybe then I can take your queries. So let me quickly explain it on the board, that if you want to count how many records are in a file, okay, then how will you do that? So maybe for that, I again, at the side of the board, I draw this, maybe this is some class, student dot data. Okay, this is student 1, this is student 2, this is student 3, 4, and 5. And let's assume that every object is taking, say, 50 bytes. Okay, so this is 0, 50, this is 100, 150, and 200. Okay, so it means that now you have 5 records, and these are the byte numbers of you can say respective records. Now we don't know how many records are there. Okay, so when you open a file for reading, say if stream f, here you write student dot dat and ios binary. Okay, suppose you want to know how many records are there in the file. Okay, and I have drawn it so you can see it, but your program does not know. When it opens the file, we know that by default your file pointer is at byte number 0. Okay, so it means that presently your file pointer is here at byte number 0. Okay, last week I also told you that you can move the file pointer anywhere in the file using the seek function. And there is also a way that allows you to move the file pointer at the end of the file, right? End of the file is here because this is written from 200 to 249, so end of file is at by 250. Okay, so if you remember, even if you don't remember, I will write it. So f dot seek g 0 ios end. Now what will happen, this will take your file pointer to the end of the file. What is end of the file? In this example it is 250. Okay, I'm just giving you this example so that you can understand. And now we can, using the tell function, because it has gone to 250 but I don't know where it is, so I can use the tell function to store this 250 in a variable. Okay, so first I move it to the end of the file, it comes here, and then I want to know what is the byte number here, where it is. So when you want to get the location of file pointer, you have tell function, and since we are using it with if stream, so we use tell g. Okay, so now this location, it will be containing, this location will be containing 250. Now somehow you have this number 250. Okay, using this 250 you can smartly do something to find how many records are there. You see, if I divide this 250 by 50, what do I get? I get 5, and there are 5 records. And what is this 50? This 50 is actually size of one record. So now you see we have a very good way. N is the number of record. What is it? Location, which was 250, divided by size of student. Now you know how many records are in the file. There are 5 records, there are 100 records, right? So now if you want to display all records, you can use a for loop from 1 to n, and you can read data, and you can do whatever you want to do with data. So you see, now we have a very simple but useful way of finding that how many records are stored in a particular file. Okay, so let me just show you this program, and then maybe we can discuss exactly the same thing on the slides. So maybe, yeah, here it is. So we have a student class object. We want to know how many records are there, and then we want to read a particular record. Okay, so I have student s. I take an object of if stream. I open this file in binary mode. This will take my file pointer to the end of the file, and tell will give me that location. So that location is in my variable end position. Now, if I want number of records, as we discussed, you simply divide it by the size of one record. If it was at 250 and you divide it by 50, you get 5. So you know how many records are there in your file. And once you know the records, you can ask the user that which record you want to retrieve. So we say, okay, what you want to read? Record number 1, 2, 3, 4, 5. So he says record number 4. And you know already this formula, this will take you, give you the location of record number 4. You can then take the file pointer there, read data and print data. So you see it's hardly 10 lines of code, but they are doing a lot of things. They are telling you how many records are there, and this part you have already seen in a previous example. Then if you say, okay, which record number you want, you can directly jump to that record and read it and display it to the user, right? So before we move further, another example, if you have any comments on this example, please let me know. Okay, now you see we have all the now machinery available in which we can using which we can write very useful practical program. Now suppose I ask you to enter data of all the students in your class, just like your student profile. So you will make a student class, all the fields which you need, and then using a do while loop, you can write all data to a file. Okay. Now suppose I ask you, print the data of all the students who have a GPA of less than 2. Okay, so that I can issue them some guidelines that they need to improve or something like that. Okay, so now you see it's very easy. What you will do, you will first write a code to open file, then you can count records, which we just did. Okay, I'm just putting together the pieces that we have done. Then you will use a for loop. Okay, because you know how many records are there, you can use a for loop, and then you can say, okay, read one record, okay, say in variable s, and then you say if, here you can put a condition. For example, if you are interested in displaying records of all the students who have a GPA of less than 2, so all you need to do, you can write s dot get GPA is less than 2, and here you can do whatever you want to do. Okay, you can display their data, or you can write a code which will prepare letters, warning letters for them, or anything, right? And you see now you can even search for a student. Okay, how can you search for a student? That you see previously the examples we have done, we say okay, I want record number 3, but you see it is not the way humans do searching. You will say I will want record of enrollment number 123. Okay, so you give a enrollment number and you want record of that student because you don't know what is record number. So you see searching by record number is actually not very useful from practical application. So now you can do that as well. How? You open a file, you count records just like we did this, and then you have a for loop. Okay, and before that for loop you say okay, what is you want to search? What is, so here user can enter the search ID, means the enrollment number of the student you are searching for. And now you can read data from file one by one, and you can use if condition, that is it the student you are searching for? If it is the student, you can do whatever you want to do. Okay, I'm just telling you the general idea. I'll show you complete program, don't worry. Okay, if I'm not writing the program, because I'm just telling you how they will work. Once you understand the working, then of course I'll show you complete programs as well. So let's say now we want to make programs for this. Okay, so let's say we are interested in printing the data of all the students who have a GPA greater than 2.5. Okay, so you see nothing new in this program, only the pieces put together. We have object of student because we in this S will be reading data. We have to read data, we create an object of if stream. Okay, then first we count how many records are there. So this piece of code, these 4 lines, it is the same code that was in the previous example. They are telling you how many records are there. First, we take the file pointer to the end of the file. Then we say, okay, what is this end location? And then to find the number of records, we say number of records is end position divided by size of student. So it will tell you how many records are there. Okay. And since I moved the file pointer, if you want to read, then that's why for reading, I take it back to byte 0. Okay. Because otherwise it will try to read from the end and there is nothing at the end. So this statement is to take it back to the start of the file. Now it is very simple. You have a for loop, I equals 0, I less than number of records, I plus plus. You read the first record, okay, which is in S. So if there are, say, records like this, S1, S2, S3, S4, you read the first one in S, and then you say, okay, if the GPA is greater than 2.5, you can call the print function, because these functions are already available in the student class. Okay, if you remember, you made these functions in the student class. So you see all of these functions are there. So since data is private, so please be careful when you are comparing many students. What they do, they will write this if s dot GPA greater than 2.5. So you see it is incorrect because GPA was private. So you write s dot get GPA. If it is greater than 2.5, you call the print function. So here, this is the code which is printing the data of those students which you want. Similarly, as I told you, if you want to search for a student, you say, okay, enter the enrollment number of the student you want to search. So the user will enter an ID or search ID, enrollment number, whatever you are calling. So what you will do, you will keep on reading data one by one. And when you find the desired record, you will display its data to the user. Okay, so you see, this is again the same for loop. We read one record, we check if this is the record user is searching for. Now you see this function get ID, this will give you the enrollment number of the student, and this is the number you are searching. So when they match, you can print the data and you don't need to search further. So you can use break so that the loop does not, you can say, keep on executing unnecessarily. And then you can do whatever you want to do with this particular record. Okay. So this was, you can say again, we with every example, we are going closer to how things would happen for a real world application, right? So if you have any queries from this example, we can discuss those. Okay, now the last thing for today is that you see so far what we have been doing. We have a class, some class, like it can be point class or it can be student class or anything else, right? And then we have main. So in the main, we make objects of this class, right? What I have been doing, I make object and I write it in a file. I save it to the disk. Or if I have to read, I make object and I read data. Okay, so you see all of this reading and writing we have been doing in the main. Okay, if you see any of the previous examples, there is a class which is separate, and the code which is reading data or writing data, where is it? It is in the main. Okay, in all the examples, you can go back and actually verify. But you see, when we are doing object-oriented programming, we say, why not do reading and writing within the class? Okay, for example, there is a function in the class which is writing. There is a function in the class which is reading. So you see, if we do that, our main will be very simplified. It means then I will not have to put that code which is reading data or writing data in the main. My main would be very clean, and everything which is reading and writing, that will also become a member of the class. Okay, so that's not very difficult. It's fairly simple. So let me give you an example. Okay, suppose we have this class student. Okay, it has all the data that I showed you. It has data, it has all the functions which are there. Okay, I will just be adding one more function in this class. Okay, so suppose in this class I make a function void save to disk. Okay, and within this function I will write the code which will save it to disk. But before I write this code, it is important to understand how this will work. Now you see in the main what I will do, I will make an object of student s. I will say s dot input. Okay, and when I want to save s, instead of writing the code in the main, what I will do, I will write s dot save to disk. That's it. I don't need to worry. Now all that code is here. So when I write s dot save to disk, which object is saved? S. Okay. If I have multiple objects s1, s2, then of course I will write s1 dot save, s2 dot save. So what will happen when I write s dot save? Whatever is in s, I want that to be stored in the disk. So now you see that it looks pretty simple. And I'll give you another example for reading, but let's first do it for writing. Okay, so let me keep the right side and let me just gain some space on the left side where I will be writing the body of this function. Again, almost similar to what you already know, except one new concept that I'll be introducing. Okay, so now this is our class student. Okay, everything else is present. So I am writing this function void save to this. Okay, so since now this function has to write, so it means all the code that you were previously writing in the main now will be writing it here. Here you can give name of the file binary, okay, that you already know. So just to save some time, I'm not writing it. Okay, and now you need to say f dot write. Okay, now this is important. You see, okay, second argument is easy. I can write here size of student, so I know how many bytes I want to write. And here I will write f dot close, and that's it, the function, nothing else in the function. But now we need to discuss what I will write in the first argument. So when you were using main, so in the main, if I'm doing it in the main, I will write f dot write character pointer, and here I will write and s, address of s, because I want to write s. Okay, but now here I cannot write address of s. Why? Because there is no s in this function. S is in the main. I don't have any student here. Okay, so you see, although you already know it, but let me just remind you that when we are in a class and we want the address of current object, we have already studied there is a keyword which is called this. Okay, if you remember, what will this give you? It will give you address of current object. And of course you will convert it into character pointer. Okay, I have less space, so you can write that. Okay, now you see, when I'm writing s dot save, you call this function, you call this function for object s, and within the class, if we want the address of current object, we already know we have a keyword this. So when you write this, what address you will get? You will get address of s, and this is what we wanted. Okay, because when you are using the write function, you pass as an input address of object which you want to write. When I'm writing s dot save, so within this function I need the address of s. So since I'm inside the class, I cannot write address of s like this. I will use the keyword this. It will give me the address of the current object, right? So you see, everything in this function is exactly the same which you already know. The only thing is that in the first argument, instead of writing the syntax like this, since we are inside the class, so I have to use the keyword this, so that I get the address of the current object. This is how this will work. And exactly in the same way, we'll be writing the read function. So let me do that, and then maybe we can discuss. So you see, first see how we'll be doing it in the main. Okay, so suppose there is a student s. Okay, and I say, okay, I want to read data from file into this object s, and this is my file. Okay, but it is possible that this file has many records like 1 2 3 4. So you see, if you want to read data, this s can only hold one object. Okay, so that's why it's better that we pass it as an argument that which record number you want to read. Okay, so maybe we say s dot read, and I say 2. So what do I want? I want that second record is read, and whatever data you read, it goes to variable s. And then you can write s dot print to display all the data of the record that you have just read from the file. So if you go and you want to write this function read, it is exactly the same the way you had written the function save. The only difference is that we are also passing it n. Okay, why n? Because n is the record number I want to read. Otherwise, if you want to read only the first record, there's no need of this n. Okay, or if there is only one record in the file, there's no need of this n. So here you can write if stream f, and then you can open the file. And as you know, how do we move the file pointer? If I want record number n, I have n minus 1 into size of student. And when you will write read, the only thing is that here you will be writing this. Rest everything stays exactly the same. Okay, so when you write s dot read, it will give you address of s. Okay, because this always gives you address of current object. And when you read data, where that data will go, that data will go in this variable s. You can actually display that data to confirm that whatever you are reading is actually going to this variable s. Okay, now let me show you this program, and then we'll conclude for today. So these are the slides, maybe. Yeah, so this is the same class student which we have already made: id, gpa, display function, get function, set function, and so on. Okay, input function where user can enter values. Now you see, we have made 3 more member functions. Okay, now these are in the class. We have a function read from disk, which will read data, and we are also giving record number, that the record we want to read. We have a function save or write to disk, which will save current object to the file. And this is a new function which we have added, because you see, we also need to know how many records are there, because that is something useful. So we have made a function count records, which will tell us how many records are there in the file. And you see, we have not frequently done that, but just for a change, I have made it a static function. Why static function? Because if you remember, in order to call a static function, you do not need to make an object. Okay, you can simply call the static function by writing the name of the class and calling that function. Now, why it makes sense to make it static? Because if there's a file and I want to count how many records are there, this is like a utility job. Okay, I don't need a student object to count number of record, right? That first I write student s and then I write s dot count record, because counting record is not linked with that student. This is like a utility function. That's why I have made it static, right? But if you don't want it, if you want to make it a regular member function, that is perfectly fine. Okay, it will still work, but just from a good design viewpoint, it's a good idea that we make it static, because we should be able to call it without making an object of the class. Now, if you see this code, it is exactly what you have seen many times in this today's lecture. We open the file, we take the file pointer to the end, we get the byte number of the last location, and then we divide it by size of one record. So this will give you how many records are there in the file. Okay, you can simply compute it and return to the user. And then these are the read and write function. Let's first see the write function. Only 3 lines of code. You open the file, okay, append mode, because we don't want to overwrite the previous data. And this is the only new part, that since we have to give address of the variable we want to write, and I want the address of current object, so I have keyword this. So just remember that whenever you are writing data or reading data using a member function, you will use the keyword this, okay, because you don't have the variable name. Variable name is in the main. And then this is the same code which we are using for reading data. You open the file, and you, if you want record number n, you go to that location using the seek function, you read data. Now the advantage would be that when you are doing this in the member functions, your main would be very simple. Okay, now just see how simple your main is. I create an object s1. This is the enrollment number, this is GPA. I just write s1 dot write to disk. Okay, now this object is written to disk, it has been saved. Of course, we have already specified the file name in the beginning. You can do it as many times as you like. And then if you want to see how many records are there, okay, you can call this function count records. And as I told you, if it's a static function, you don't need object. You can write name of the class, scope resolution operator, and count, and call this function. Okay, if you don't want it, if it's a regular function, you can also call it with the dot operator, like count records, just like you call any other function. Okay, so now it will tell you how many records are there. Since there is only one record, so we say, okay, let's read the record in another object, right? Instead of s1, now I take another object s2. I say s2 dot read from disk, and this is the record number I want to read. Since there is only one record, so I'm passing one. And if you want to verify, you write s2 dot print. Okay, so now exactly the same data should be printed which you had written, and you can confirm that that okay, whatever I had entered, the same data has been printed. Now this is writing one record, but you see now it's so simple that you can use a do while loop. You can ask the user, okay, how many, keep entering data as long as the user desires, and you can put all of this piece of code in a do while loop to enter as many records as you want. So you see, nothing new. We are gradually making our programs more useful. So this is a do while loop. We say enter data for student, s dot input. So we'll enter data to student, that object is written to file. So you see, these 3 lines are doing it for one object, and I have put it in a do while loop. So now you can keep on entering data as long as you want. When you don't want to enter any more data, you will come out of this loop, and in the same program, then you say, okay, or maybe it can be a different program as well, it's your choice. Okay, so you say, okay, how many records are there? I count the number of record, and then I display each record. Okay, so I have a for loop, and I say s dot read. So I read the first record, second record, third record, every record, and I print it. Okay, you can of course use search in it, or you can do anything else that you want. Okay, so this was you see, now our examples are much close to what we expect from a real world application, as compared to where we started at 11:30 or 10:30 maybe, right? So you see, within these 2 hours, we have gradually moved from writing a single integer to a file to writing complete objects to file. We are able to search those, we are able to directly jump to any record in the file, and we can display it, right? So I understand it was a relatively heavy session for today, but the New concepts were read and write function. In all of the examples, we have just exploited those functions with our previous knowledge, like seek, tell, do while loop, and so on. And we were able to write very useful programs, right? So we have some time for discussion. So if you have any comments, we can discuss those.